The mole is one of the fundamental concepts of chemistry. It's a very important thing to learn about and be able to calculate with, because the mole relates all chemical qualities and quantities to each other. Here we just have a little bit of a humorous depiction of the mole, but very much so the mole is different than the pictures here. The mole is actually the measure of a pure substance. It is the SI unit for the amount of pure substance. Now when we're talking about pure substance, we're talking about several different things. Specifically, we're talking about non-mixtures. So different pure substances that come to mind are atoms. Those represent elements, molecules, and the never to be abbreviated formula units. These are examples of pure substances. Now remember, atoms come from elements, molecules come from covalently bonded compounds, and formula units come from ionically bonded compounds. The person who really put this whole thing together was named Avogadro. And Avogadro's number depicts a very, very large quantity, and that quantity is 6.02 times 10 to the 23rd power. And that's 6.02 times 10 to the 23rd atoms per mole, or molecules per mole. And this is a very important number in chemistry. It is a big number because it's representing things that are very, very, very small. In order to make them tangible in the macroscopic world that we live in, we must have a great deal of them. This right here is what we like to call a mole map. Now the mole is the center of this map. It is the center of everything. It's how we relate the number of particles to the mass to even volume, which we'll talk about later on. Anytime you're traveling in toward the mole, whether you're starting with particles, mass, or volume, anytime you're traveling in, you're going to divide. Anytime you're traveling away from the mole, you're going to use that same conversion factor, but you're going to be multiplying. We're going to work with this, so you should become familiar with this mole map. Okay, so let's take an example here, and let's work using the mole map and see if we can figure it out. So the first thing that we're going to do is we're going to convert from moles to particles. So specifically, that is this section of the mole map, this lower section right here. So in an example, let's say we have 5 moles of silver. And we want to know how many atoms of silver that is. Now we're talking about atoms because silver is an element, and again, the representative unit of an element is the atom. So we're going to set up a very simple ratio, and we're going to focus on one of these two things here, either this one here or this one here. Well, since we're starting with the mole and heading in this direction here, we're going to follow this arrow. So we're going to set up the ratio of 6.02 times 10 to the 23rd, I'm just going to write E, atoms on top, over 1 mole on bottom. And again, it's atoms because we're talking about silver, an element. The value obtained when you multiply these together is 3.01 times 10 raised to the 24th power. And again, silver, so we're going to have atoms of silver. If I were given atoms of silver to start this problem and asked to find moles, I would simply take the opposite direction, and this fraction would be flipped. The next part of the map that we need to explore involves another tool that we need to learn about, and that's this thing called molar mass. This is one of the easier things to define because it's the mass of 1 mole, which makes sense. Now, when we're talking about the mass of 1 mole, we're talking about 6.02 times 10 to the 23rd particles of that particular substance. Each substance is going to have a different molar mass. So think about if you had like 12 bowling balls and you had 12 feathers. The 12 feathers and the 12 bowling balls, well, we have 12 of each, but they definitely don't have the same mass. You take the mass of one of those things and multiply it by the number that you have, in this case 12, to get the total mass of your dozen. Well, when we're talking about elements, the molar mass is simply the atomic mass. But when we're talking about compounds, it's the sum of all the elements that make up that compound that results in our overall molar mass. I have some rules to help us with molar masses. If on the periodic table the element ends with an atomic mass of 0.9 or 0.8 or even 0.7, we'll leave 0.7 out of it. If it ends in 0.9 or 0.8, we're going to round it up to the whole number. If it ends in something between 0.7 all the way down to 0.3, we're going to round to 1 decimal point. And if it ends in 0.2, 0.1, or 0.0, we're simply going to round it down to the whole number. Very few elements in the periodic table actually end in whole numbers. We'll be using this as we develop this problem and as we work with this. So let's do an example right now. If I had the compound CuCl2 and I wanted to find the molar mass, I would say, okay, I have one copper atom and I would multiply it by the atomic mass of copper. Now copper is actually 63.546. But in order to simplify this and make it a little bit easier for us, we're going to look to follow the rules from this previous page. So if you look at copper again at 63.546, you'll find that it ends in 0.546. Well, since it ends in 0.5 something, we're going to take that and round it to 1 decimal point. So we're going to call it 63.5. That's 63.5 grams per mole, which is the expression or the unit of molar mass. 1 times 63.5 equals 63.5. We're then going to look at chlorine. In this particular equation, we have 2 chlorine atoms. Each chlorine atom has an atomic mass of 35.45. Again, using our rules obtained from the previous page, we're going to plug in to 1 decimal point. 2 times 35.5 is 71. When I add up these values, we find that copper 2 chloride has a molar mass of 134.5 grams for every 1 mole. This is a molar mass. What this means is if I had exactly 6.02 times 10 to the 23rd formula units of copper 2 chloride, it would have a mass of 134.5 grams. Alright, the last thing that I want to explore before we kind of close this video out is exactly how we're going to work with this molar mass idea. So if we look at this bottom section of the mole map, move it to this side, we're looking at the mole being found over here going to mass found over here. And the tool that we use to get there is molar mass. So if I were to start with, say, 3 moles of copper 2 chloride. Again, if I'm starting with moles, I'm starting right here in the middle. And I'm going to make my way toward mass. Well, the arrow pointing in that direction is this one right here. In that case there, what I'm going to have to do is I'm going to have to take it and put molar mass on the top. Well, from the previous slide, the molar mass of copper 2 chloride is 134.5. 134.5 grams for every 1 mole. What we find here when we multiply 3 moles times 134.5 is that 3 moles of copper 2 chloride has a mass of 403.5 grams. We'll be doing lots of practice with this in class, but this is a good video for you. I highly recommend that you kind of make this one of your favorite videos because you're going to end up having to watch this one a few times.